This conference will now be recorded.
All right. Good morning, everyone, and thank you for joining again. We have a couple of new people here from, I'm not sure if I'm pronouncing this correctly, Tiny Bay. Am I right, Dr. Carl? Yeah, maybe you guys
Yes.
could take a second to introduce yourself.
Sure. Thank you very much for the invitation. I'm Carl Schubert. I'm the Chief Scientist and Strategy Officer for Tiny Bay. We're a cloud native company, open platform company. And in past lives, among other things, I was a Dell Fellow and the first CTO at Dell and created started the Dell Storage division and then done startups since then. And so my colleague, Rohith Reddy, is just coming on. And Rohith, do you want to introduce yourself?
Hello all, I've been an entrepreneur for the last decade and I'm currently the co-founder and CTO at Tiny Bay. We're building a observability and monitoring platform, and apart from that, we're also a cloud native consulting company. We're one of the certified Kubernetes service providers in US. And we're really looking forward to engage with you all.
Thank you, Carl and Rohit. So yeah, the reason Rajiv reached out to me, I believe you guys are working on some sort of test for OCP hardware, and this group is trying to standardize the test specifications for OCP hardware as well. So your input here will be invaluable for us, I believe. So thank you for taking the time to join us. I believe you guys are already working on a piece of software and it's going towards beta release at some point, right? If you guys could share a little bit more about that. Or are you guys not ready to just talk about that yet?
Sure, we can share a little bit. Rohith, do you want to?
Yeah. So basically, we're building an observability and monitoring product on top of cloud native ecosystem, primarily focused at helping resolve incident management better using AI. So Carl is basically leading the AI part of it, and I lead the monitoring and observability part of it. The idea is to make site reliability engineer more efficient for site reliability engineers and DevOps engineers. That's the high level. But on the product side of it, we are looking to integrate it with the infrastructure side of it in terms of building our own version of the Kubernetes version, which will kind of integrate with the hardware side of it as well to get the monitoring data from the infrastructure side of it. So that's a very high level thing, and I think we are a few weeks away from our beta release, and I'd be glad to kind of present more details once the beta is ready.
Thank you. We're looking forward to the beta implementation. So thank you for being here. And we will learn more about this piece of software when I guess you guys go to beta. Cool.
Just quick question and welcome, Carl Rohit. Is the work you're doing planned to have sort of a proprietary aspect as well as an open source model? Are you doing sort of both, or is it purely based on a service model?
It's actually both.
Open source as well as proprietary?
Yes.
Okay, thank you.
That's good. So on to the next topic, which is the OCP Summit presentation. I did have a couple questions here for Google primarily. Dan, I know you guys wanted to present as well. We are currently looking at using the Delta Lake system. Would you like to use that system as well, or is there some other piece of hardware that you guys want to be using?
No, I think, one of the things we're trying to sell is the thing is somewhat hardware agnostic, so I think the Delta Lake would be just fine.
Cool, that works. I believe, and on that topic as well, 9Elements has set up a system for us. They will be able to give you access, please go in and fill out the sheet that Christian has put inside the meeting minutes for access. And Vincent and any other team at Facebook, do you have any requirements other than the Delta Lake system for hardware?
The only challenge is going to be just getting a Gen 4 and Gen 5 systems for the PCI crawler development, but we can take this offline. I don't think we need to resolve that on this call. That's the only hurdle I can see. A point of detail.
Thank you for that. Cool. All right. With that, let's dive into the presentation by Dan and Yanlin. Thanks for taking the time to put this presentation together today.
Before we do that, Paul,
Yes, Rajiv.
so for the GitHub account creation, I think I did send invites to you guys. Anybody had any issues in what you call accepting those invites, or you guys are good? Because I haven't seen anything yet. I mean, it's pretty blank right now. The repo that I created.
I have accepted the invite, Rajiv, so it worked for me.
Okay, and Paul, I'm just trying to make sure what is the objective. I mean, I understand this, but what exactly is the end goal for this effort?
Two-pronged, right, Rajiv. The first thing is for us to kickstart our collaboration on the PCI specification. I think Giovanni requested this space so that it's a open space for us to actually be able to edit things with a record. The other area, eventually this will morph into the repository that hosts all our diagnostics, right? So we'll eventually have a place to store all the work that we've been doing, that we're going to be doing in this forum as well.
Understand. And one question, I don't know how wild that question is. This PCI crawler is open source. Is there any plan to transition this open source to the OCP GitHub or to OCP?
That's not something we've discussed yet internally. Currently that's being maintained by Facebook, but that's a conversation that we can have as well. So I'll table this and I'll take this offline with you.
Sure.
Please include me in that chat, Paul.
Absolutely, Vincent. All right, with that, let's go on to Dan and Yellen.
Hey, Paul, before we start, I do have one quick logistical question on the OCP Summit. A lot of us received emails for signing up for a speaker profile from an unknown email address, fntech.com. And I noticed it went to my spam folder, probably because a lot of emails got all sent out at once. Is that an address we should be trusting? I wasn't familiar with it. It didn't come from the OCP.
So I can take this, Paul. Yes, Dan. FNTech is our media company, and they're the ones who organize, maintain, logistics, everything they do for OCP. So any email that you get from FNTech Review or FNTech Portal is a valid trustee. So
Okay, sounds good. Just wanted to make sure before I put my social security number and credit card in there.
No, you're safe. I won't take the responsibility though, but you're safe.
Okay, all I heard was Rajiv will take responsibility.
Oh, no.
Fair enough. Hey, Paul, would you mind presenting the slides?
Turn the recording off for a while.
Absolutely. Let me share it. By the way, another logistical thing before we also really get started here is that I created a Google Drive where all these documents should live. So I will start saving all the presentations that we've been putting to the Google Drive for future reference for anyone joining this forum. So I have invited everyone, I believe, that's on this group. So if you do not have access, please ping me. And with that, I will start this presentation. Let's see.
Okay, so Wan Lin and I started throwing together some slides for this late last night, right? And there's a lot of slides, so I'm going to fly through some of them. Some of them are things we've kind of talked to death about, like the output format, things like that. But some we haven't really talked about yet. And I wanted to cover those things so you guys can kind of get a big picture of like what Melton is, why we did it, where it came from, and then hopefully how we feel it fits into the bigger picture that we're all working on now. So if you could go ahead and go to slide 2 there, and I'll just say next when I'm ready for you to move along. So as I mentioned, we started Melton before the OCP involvement, before Paul, you invited me to join this, right? And it really sparked out of, problems that we had when we were working with the external equipment vendors, and also integrating sort of our test systems into other environments and then sharing those tests with other people, right? So I wanted to share today just sort of what we've done so far, but then stress the fact that we're open to changes, we're open to new ideas, refinements, right? But maybe this is a way to kickstart what it is we're trying to deliver in November. Next. So first off, what is a Melton? Because I didn't know either. It's actually a Pokemon. That's where the name came from. This is the one slide that I'll remove before we share this with the group. That's what a Melton looks like right there. And then probably the more serious slide about what is Melton is next. And for us, it's a set of portable core libraries that basically give us a multi-language solution for creating portable diagnostics that we can integrate into a whole bunch of different test executives and then larger platforms that the test executive might only be a part of, right? We have a data center platform. We have several different manufacturing platforms. We have a validation platform. What Melton really aims to be is sort of that lowest common denominator to take care of a lot of the busy work of creating the diag so that the diagnostic engineer can really focus on writing the diagnostic and less on the plumbing, right? So it makes very little assumptions about where it will run, what assumptions are needed. It handles getting data in and getting data out, right? And we also provide some other helper things that we feel are sort of basic to every diagnostic. One, we have a hardware abstraction API that we'll talk a little bit about. And then there's also a communication API for when you want to run some series of tests off the DUT and maybe communicate with the DUT. Typically, that's done via a couple different mechanisms. Every environment we run in has different security requirements. So we provide a plug-in model for allowing different providers to say, this is the way we do communication. The one that we provide by default is SSH. That's typically what runs in our factories, and inside of our data center, we have a different, communication mechanism with machines. So why did we do it, right? Historically, we've been a pretty isolated technical island. Our solutions are pretty good, at least we think they are. But as I mentioned, operating with the outside world, it's always caused that impedance mismatch between Google and everyone else, right? A lot of our technologies are starting to become more open. gRPC, protobuf are now all open source, but the level of adoption in the outside community internally, there's still a big gap, right? So we're looking at providing a portable solution for diags, giving a really simple interface that we think we can plug into anything. And then ultimately, we're hoping this will result in a very large library of common diags shared across the OCP members. Just make it easier for hyperscalers to evaluate hardware, ingress that hardware into their data centers, right? We want to shorten that NPI cycle, particularly when we're dealing with off-the-shelf items or OCP items. So before Melton, we had something that sort of looked like this, right? We said, hey, we need to run all these tests at various other locations. Let's rip out our data center infrastructure and put it everywhere. So we had a test executive, and then that thing talked to this diagnostics as a service daemon, and it communicated through protobufs and RPCs, and there was some REST thrown in there as well. And then the diags themselves, had a whole bunch of plumbing to support all this, right? But we quickly realized the only thing people really care about, they care about the test. And if you just sort of looked at lines of code, all this stuff was probably 80 or 90% plumbing, right? And that's where we wanted to get out of that and where we wanted to go with Melton. We've talked about this a little bit. I'm not going to spend a lot of time. We're not trying to be a test executive here, right? What Melton really is trying to do is give you one interception point into our diags with various test executives so that we're not wrapping every single diag, right? And we can move on from that. I don't know that I want to spend a lot of time here. This is just sort of our belief of where the test executive ends and where Melton begins, right? We don't get into sequencing. We don't worry about PLM. We don't worry about control systems. We don't worry about putting results in a database. We don't worry about the life cycle of diagnostics. We don't worry about installing the diagnostics. We're looking for other infrastructure that's not us to do that because everyone does that differently, right? In some cases, even though we strongly believe that diag should pass or fail, other folks take a different opinion on that. Some feel that diags just provide data and then some other higher level system makes a diagnosis, right? So we want to be able to support that model as well with our diags. So there are a couple areas with Melton where we've tried to be as generic as possible. The two areas, and we've talked about this quite a bit as well, is that we feel we had to be opinionated are the input arguments and the output format, right? Because we feel that there's just no other way to do it if you're going to really achieve that one, promise of a single point of integration for all diags, right? You write an adapter for once and then it works with everything, right? For say test stand, for us it's open test and another test executive we call burn-in. For the solution from Keysight, all of that, right? That's where we're looking to target. Parameter is sort of the same thing, right? Same argument with what goes out. Almost the same argument has to be made with what comes in. In a lot of cases, the parameters to diags are very simple. They're ints and floats and strings and things like that. But other times we had more complicated, parameters. It might be a set of limits, right? It might be what we want to allow pass or fail for a particular eye diagram, right? For those cases, we want to be able to support those models as well, right? So we do have a fairly comprehensive schema for how we allow arguments to be passed into Melton. And Juan Lin will talk about all the details, and then we can kind of get into technical questions. So ultimately, why the OCP and what would we like to see here? We'd like to see alignment on a standard across the industry, right? Our end goal for Melton is to be a compliant implementation of a larger standard, right? If no one adopts our implementation, we're totally okay with that. As long as others are sort of bringing their own and we can kind of get on this lingua franca for diagnostics, then I think we've achieved what it is we want to achieve, right? There's still some other errata that will make that a little bit complicated and required parameters that we need for a diag to work with, our internal systems, right? But those things we'll get to. I think if we can get to this place, we're in a really good spot. And that's ultimately where we want to be and what we want to achieve with Melton. So I would say before we get into the technical topics, does anybody have any questions about that? And then we can get into specifics. Okay, in that case, let's turn it over to the Melton expert, Juan Lin. She's our technical lead on the project.
Hey everyone, this is Yuanlin. I'm currently leading the Melton project within Google. Can we switch to the next slide, please? Right. So here are all the hardware diagnostic modules we put together. So starting from the test executive, it will install and run the DEX. As Dan mentioned, this is where Melton DEX start. And since we already know that there is some reboot test, for example, that requires like off the machine monitoring. So we split our DEX, we categorize our DEX to off machine DEX and on machine DEX, which is like off machine DEX is running remotely and communicate with the DAT, and the on machine DEX is running on the DAT and try to get the information from it. With the procedure one, which is install and run the DEX, we have the protocol called the parameter model that we will dive into later. on how we define the parameters and how the test executive can communicate with the DAGs and pass in the parameters. And the second part is what we call hardware interface. Basically how we communicate with the machine. Either we like talk to the CPU or talk to the BMC or some daemons on the CPU or BMC. And then when test finishes, it will send the output from some like result model. This is what we have been talking about, the result schema. It will send the results by JSON-L to the test executive's backend store and then surface it up in some test executive UI. Next slide, please.
Hey, Wenlin, would you mind
Yeah.
if I interrupt with questions, or would you prefer we hold them to the end?
No, feel free to ask questions.
Yeah, just a quick one on the previous slide. Of all of this, what are the boxes that make up Melton?
Right. So the off machine DAX and on machine DAX and every arrow connecting. So the off machine DAX and on machine DAX is the blue box are the Melton executable, and
Got it.
everything, yeah, every arrow connecting them are the Melton APIs or handy like libraries we provide.
Thanks.
So we'll start from the parameter model. This is an example of how we define and how we set the default parameters. So we usually define, like since it's Google, we usually define the parameters as a proto. And on the right top, there is a MLC test that we put together, and the parameters include all the like internal bandwidth, intra-node bandwidth, and the latency thresholds, etc. When we define the proto, we also define a default JSON parameter. So here we only define two parameters. The other are all like proto buff default. And when we have the executable, when we build that, we automatically support a dash dash help, where we can send all the parameters as flags. For example, the field name in the proto will become the flag name in the dash dash help. And then the comments will become the description of the flag. The tab will be translated in help, which is the proto tab. And then we also have a default value, which is also defined in the JSON profile, JSON default parameters. All of that is provided by something we call parameter launcher. So it takes the proto definition, it takes the default parameters, and then it automatically translates to that to the POSIX flags. And here we talk about the parameter override. I'm sure I already mentioned some of it last meeting. So we also support the dash dash dry run, which will print out the default parameter. And we can also accept the parameter override by JSON as well from standard input. So here is an example of when we override internal bandwidth minimum to 100. So the new parameter combo will be like that parameter equals 100, and then the use default thresholds override it to false. And on top of that, we also let the command line flags override the like standard in override. So here is an example. After we use the command line to set the internal bandwidth to be 200, then the final parameter combo will become 200. So for the results schema, I'm sure we've talked about this a lot. So we comboed our output artifacts to test run. Oh, I think this need to update, but so basically we categorize our output artifact to test artifact and test step artifact, where test step is the logical steps of a single test execution. Next slide, please. This is an example run of how to virtualize what will happen when we execute a test on the DAT. And the next slide will like show in the diagram how the result is grouped together. Yeah, so for example, if we have a MLC test, we take the parameters, we take the data infos, and then the first step will be like the bandwidth check. We send a group of measurements measuring the bandwidth between the CPUs, and then we send diagnosis for each CPU to tell the test runner if it's a pass or it's a fail. Same for the latency check. So this is like one Melton test with two Melton steps. And this is what our API look like. So we have a object called test run, which is so this object is kind of a helper to help us dump all those like Melton output result. You can see there's like initiate, there's start, there's end, skip, all those like different executions we can use. Just to note, just to like highlight that if we don't call end or skip in the end, it will automatically call end and skip when we finish the test, or when we say when test run object is out of scope. Similar to test run, we also have a test step object, which is helper to dump all the test step artifacts to standard output. Another object is measurement series. Don't know if everyone is familiar with this concept. This is a time series of measurements. So we can start a measurement series and then add different kinds of element with different kinds of limits. And like we made it an object because we don't want to hold all the elements before we send a series. So this can be like restful in the way that we can like dump each element one time instead of cache all the measurements or the statistic data as we run the test. So this comes to the second part on how we communicate with the hardware. The green box is what a Melton DAG is, and the blue box is what we call hardware abstraction layer, and the yellow box is all the backends. Like the first four backends are what Google is currently use, and you have like it can also be customized to have its own like backend. So what happens is the Melton DAG will talk to the hardware abstraction layer, and depending on the config, it can talk to different backends. So it can be used cross environment if they use different backend with different authentication, or if we use different backend in, for example, manufacturing test and production test, then we have an easy way to configure that. So what happens is the Melton DAG will pass a config to the abstraction layer, and the abstraction layer will return a client that the DAG can use, and then the DAG can like get the resource information from the hardware abstraction layer, and underneath it can talk to different backends. So 3 and 4 is the how we like query information from the DAT, and we can use the client as many times as we want, and 5 is just to repeat 3 and 4. So this is an example of how we use that backend interface in the real test. For example, if we have a CPU test and we want to get the CPU info, and we set it to be like, for example, this is the host interface, which basically runs random commands on the host to get the information in a format that we predefined. So hardware interface will like talk to use command like lspcu, cat CPU info, all those commands, and parse it to like some of our pre-defined proto. We use proto in Google, but of course we can use other definitions as well. And then the hardware interface will give the CPU info back to the CPU test.
I have a question here.
Sure.
So looking at the hardware interface, I'm trying to figure out like what is the communication protocol to the dot here, right? So LSCPU obviously is a command line, but um, how is that being determined?
Oh, yeah. So, for example, in the get CPU info, we pass in a get CPU info request. And in that request, we will define, for example, we want CPU frequency, we want CPU part info, and we will define what information we want. And underneath, like, if you are asking what command we use, if it's just if it's the hosting, if it's sorry, I can share my icons.
Sorry,
So
can everyone mute if you don't mind? Then I think it might be you actually. Yeah, thank you.
thank you. Yeah, so these are like standardized Linux commands that we can use to get the CPU info. Like we will also like of course get the OS information, get the like architecture information before check those information before we run those commands. Basically the library will configure itself to run the like generic commands that can support basically most of the platforms.
Right. Actually, what I was kind of thinking of was you have a HTTP command here, right, to go query a probably off unit dot, right? So basically, what I'm trying to get at is how are we defining the transport protocol from the hardware interface to the actual hardware itself, right? I think earlier you
Right.
had a slide that basically showed off-duty diex and
Yeah,
going to the diag and things like that. So I was kind of curious, like, where are we defining that?
we will go through that in next slide. Actually, the slide after that. So
Awesome.
yeah, we
All
can.
right, maybe I'm just jumping ahead of myself. Thank you.
Okay. Yeah, so this is the hardware abstraction API that we put together. So there's a service interface. Then we can send a config and like return a service client. And then we can also call create to create a client and return the status. There's also all kinds of like get resource information kind of calls or libraries that we can support. And it's not thorough, but we just use CPU info, arrows, file info as an example. And the next slide is 24, please. Yeah, next slide is how we put together the off-that machine interface. So we have some like libraries that we define together, like we put together for how the like this how the test should communicate with the machine of the that. And we basically provide read files, write files, and run commands. Sorry, I didn't put the so we should accept, for example, the common access interface like password, like the access tunnel, as an argument. But I may not paste it here. So in the command line option, I only put the standard out file and the standard arrow file as a optional parameter. But so in real implementation, we also have the option of the common access tunnel, like the password, like the which port you want to talk to, and which IP you want to talk to, the kind of parameters.
So in the Melton model, here's a question, right? Is the transport protocol baked into the Melton model itself, like basically, are we defining it as SSH, or if I suddenly wake up and decide I want to use Telnet as for some unknown reason, like would that be something that is like is adjustable in Melton, right? Or is that just hard coded into the diag
It's,
itself?
it can be adjustable by flags. We definitely support some machine interface connection tab, and we also support the remote asset tunnel file path that where you describe the like all the asset connections you mentioned.
Cool. Anyone else have any questions on this?
Yeah, first of all, awesome presentation, Wan Lin. This is really informative, very well put together. I was curious about the interface between Melton and the hardware interface itself. It sounds like they're more a full package solution, not trivial to disentangle. I mean, is there would you say you can actually get sort of the spec of yeah, going back to that slide, can you decouple sort of the Melton diag from its hardware abstraction layer, or at runtime effectively they just all need to be packaged together?
Yeah, sure. The Melton desk can be decoupled with the hardware abstraction. So the abstraction layer is just a library that you can use. If you don't want to use that and just want to execute something on that, sure, feel free.
Yeah, and that's kind of what I was wondering. Like, if I take the MLC as an example and wanted to drop it into, there would be a requirement to implement the hardware abstraction handlers, right? I see Dan shaking no. That wouldn't be required.
No, it would not be necessary, right? If you wanted to call that directly, you certainly could. The hardware abstraction layer there is, it's an optional feature to use.
I see. Okay. And the last question I have is around the runtime requirement. I think we touched on that on a few previous meetings. And sorry if it also got covered in some that I missed, but are there any runtime hard dependencies for Melton to exist and be installed?
We've talked about this internally as well, actually. So currently the Melton Dex is running on Google Runtime Environment, which is GRTE. So for now, we would anticipate we need DRT to be installed first before we can run Melton Dex. But we also discussed internally as well if it makes sense for us to remove that dependency. And
Yeah,
other than
just for the folks that may not know what GRTE is, it's basically glibc with some bug fixes and things like that Google has added to it. But like really, that's our lowest layer dependency is glibc, so we're pretty low, right?
Okay.
Thank you. Any more questions from anyone? All right. If not, thank you, Yulin and Dan, for the awesome presentation. This was very informative and helpful. Let me figure out how to stop sharing. Dan,
Yeah,
is it
I'll
okay
jump in if you don't mind, Paul.
Go ahead.
Sorry, just
Yeah, please go ahead.
my brain is catching up to me. Maybe a question that goes back to Rajiv's initial question, Dan, Wan Lin, when you're looking into Melton, exposing Melton, are you looking at a particular licensing model, or is this going to be, because I know OCP has a particular license, and I think when PCI crawler was getting open source, there were a lot of discussions around whether to put it in the OCP license versus other licenses. Is that been considered already, or?
There's 3 licenses that Google basically allows their stuff to be released as. They're all very permissive. One is the MIT license, right? We trend to stay away from the politically charged word parasitic licenses like GNU and things like that, right? But the one that generally we try to go towards is the Apache license, which I think is one of the most permissive. It basically says do whatever you want with it, just make sure we get some attribution in it. And that's probably where we would go with Melton, unless that's a conflict with the OCP.
So if I understood correctly, I mean, we support all the OSI supported licenses. We do recommend MIT to be the de facto. But if any company has certain choices like Apache 2.0 or GPL 2.0, 3.0, FreeBSD, and things like that, we are open as well. But it must be an OSI license. That's all.
Yep, no, that sounds good to us. And we like them all with the exception of maybe the LPGL, right? That's the only one that we're a little leery of.
Yeah. Okay.
Thanks.
Awesome. Then before we move on to the next topic, is it okay if I upload the slides to the share drive for everyone for reference?
Yeah, it is. Let me just send you a text out of band saying go ahead and do it. I just want to go through the backup section. I wanted to leave some things in there in case questions came up and we wanted some slides, but there might be some things in there I want to sanitize, and then I need to get rid of the melting guy so Nintendo doesn't come after me. But after that, we should be good to go.
Sounds good. All right. On to the next topic, which is basically next steps for the PCI standardization. So Dan and Vincent, I think we had a side conversation about what are the next step forwards. Dan, you provided your input. I think those make sense. Vincent has actually agreed to updating the PCI crawler test. I believe we wanted Gen 5 support, right? Inside PCI crawler as well, if I recall. Right.
I think for us, the main thing we were wanting to be concerned about is just that we supported capturing the AER registers, right? PCI Gen 4, Pin 5, I mean, yeah, that'd be great, but it's really more the AER registers that I felt like, give it a really compelling, diagnostic story, right?
That's fine. Yeah, I kind of remember that if we needed the requirements for PCI Gen 5, but if we don't, then we can take that off, and that makes our life a lot easier. Vincent, so Vincent, I think you've agreed to help update this thing. Is it possible if we could get an ETA from you on when you think this would be done?
Let me finalize the ETA next week. I did look at PCI crawler this morning. I did see an option to collect and decode and report AER, but I need to see what's missing and what the story is there. So I had not looked at that repo for some time, but I'll get the ETA next week. I have a few people that working with to see what needs to be done. It may already be done. That would be, unless I missed. But I'll scope that and report back next week, or on the Slack channel. I'll just confirm if it comes up sooner.
Okay, that'd be awesome. And it may be that, just like you said, I missed the flag when I was looking at it, right? Because that did seem to be the one really obvious thing that wasn't there. Everything else seemed to be
Yeah.
covered.
Yeah, the thing that caught me is, we used to call this tool internally PCI tool, and then it got renamed PCI crawler. But the tool we use in manufacturing does not have that option to collect AER at this point. And so when I looked at PCI crawler on the GitHub repo, I saw it and tested it, and so anyway, I'll follow up on that. It may have been a more recent addition.
Awesome. So I believe the next steps we talked about was how would Google incorporate this diag into Melton. So that would be the dependency for that. And Facebook on our side, I believe, Vincent, would this integrate into Fava as well?
I would definitely not want to pass on that opportunity to have that bridge. There's definitely a lot of good value there to get diags opened up into Fava. So yes, screaming yes.
Absolutely awesome. Tobias, from your side, I'm not sure if you have integration into this as well, because I think we're going to present this at the OCP summit. That's why I'm asking.
Yeah, we wanted to work on the integration. This looks all awesome and fits our model very well, so that should not be rocket science.
Awesome. So in the meantime, I think the parallel track would be to finalize the output and inputs of that. So we still haven't fully reached a decision on the outputs yet, from what I understand, or are we just all in consensus with going with the Melton format at this juncture?
Yeah, I think
Ben?
we need to get it out there so you guys can kick the tires, right? It's one thing to look at a presentation, but it's another thing to be like, why can't I get this freaking thing to build, right? You know? So I want to make sure that we do that. And then, something I would like some feedback on the team for. One thing that I was kind of concerned about was that, inside of the way, or I would say inside of our implementation, that's probably the better way of putting it right now. Like, you touch the protos, you feel the protos, right? And that for some people may be a turnoff for adoption. I was thinking we would wrap those in helper functions and things. That's way if you're like in Python, it feels Pythonic. If you're in C++ rather, it feels like C++. It would be interesting to know what people think once they get a chance to see what we have right now, as far as, making sure that we make this super easy to adopt. Like protos aren't complex, but the first time you run into them, there's some weirdness about them, right?
Yeah, I mentioned it will be very different for us to kind of execute this in our environment. So yeah, thank you for offering. That'll be great to were you thinking of putting it on the GitHub repo, or how would you like to get this kickstarted then?
So I've actually got to go through our open source software license. I think we've jumped through all the hoops that we need to jump through, so it's a matter of probably a rubber stamp yet. There's a couple things that I want to clean up before we do that. We've got some parser issues that I want to make sure are resolved now that we're starting to use Melton at scale. We're starting to see like integration problems where, oh, you're on CentOS OS and it works a little bit differently than we expected, right? We want to get those things ironed out, but it shouldn't be long. We should be able to get those things done pretty shortly.
Do you have a timeline of when you think that would be?
I don't, but I can get you one. Let me get back next week.
Awesome, thank you.
Yeah,
on that line.
Sorry, go ahead, Vincent.
Sorry, Dan. Finish your thought if you want. I was going to ask something slightly
Yeah, no,
unrelated.
my answer to Paul, I was just going to say, originally there was no real pressing need to open source it. We were continuing to kind of work on it internally, but now I think we're probably, there's more compelling reason to get it out sooner rather than later.
I agree.
Yeah, and my question was gonna follow that is around the contribution model. As you said, I mean, yeah, there are certain things that, depending on the runtime environment, are gonna inevitably, invariably just come up. Are you looking at an open contribution model where, if Tobias or myself or anybody on the teams who are working on it would pull requests, or are you looking more of keeping it more private to start?
No, so I don't want to do that. This is somewhat of a personal diatribe here. These are Dan's thoughts, not necessarily Google's thoughts, right? Or I guess even the OCP's thoughts. But we usually come up with pretty good technical solutions, and then we just flat out suck at governance, right? Like we aren't good at that. Like people will throw things out there, and then we're like, no, we don't like that. We're not going to take it, right? And we open source, or I should say, we put our source in public, but we develop in private, right? I don't want that to be the model for Melton, right? That's not where we're trying to go here. We probably will have to set up some type of governance committee. I'll be honest, I haven't had a lot of experience in this area, but I also want to make sure that we've got headcount to support, bug fixes that get introduced and everything else, at least initially, right? So yeah, I mean, Vincent, that's what I want to do, right? I want to make sure that we've got the folks there to support it because at least initially, this won't be a net positive gain, right? It's going to be a resource drain while we get this thing kicked off, but I think it will pay dividends later if we pay the investment now. That's my feeling.
Yeah, sounds very good.
Another thing that I really want to get some feedback is on the build system. So currently inside Google, we use something like similar to Bazel. And like I've tried to build a Melton deck outside of Google, and it's pretty straightforward. Just install Bazel and then run a single command to build it. But I want to see how the industry is familiar with Bazel and how acceptable like the, the guess can be if we introduce that into a dependency. Otherwise, like Bazel has like a native translation to CMake, but there might be some toils there when proto come into the picture. But yeah, just want to see if we need to investigate to make sure like CMake can work.
Yeah, I think to add to like Wanlin's point there, like when I got PCIe crawler from you guys, I didn't have to build it. All I had to do was keep installing packages on CentOS until it ran, right? Like I want to get something closer to that model, or if we do have to build, and I think we do because we're looking to support multiple languages, just make it as easy as possible, right? Like in my dream, it'd be a make file, but we probably need something a little bit more complicated than make.
Cool. Yeah, I'm sure that will start exposing itself once we other people start running Melton on different OSs and different flavors, right? So yeah, that will definitely come up, and we'll be sure to give you feedback on that. Awesome. Anyone else have anything else to bring up this week?
Just one somewhat tangential issue, and our
Sure
new
thing.
friends from, I'm sorry, I'm blanking on the name, may be interested in this as well. As I was talking to some of the OCP folks that are working on the telemetry model, and they are also somewhat interested in looking at some of the ideas and where we might be able to align there. They think we've got some things that are good as far as the way the hardware identifiers work and things like that. So I'm also going to start to drive some things with them, but at the same time, I don't want to over encumber this particular group with a new set of requirements, right? But ideally, more convergence is probably better.
So no, Dan, I completely agree with you. And when I looked at one of the slides in the presentation that when shared, you had the Melton diodes and the hardware layer, and on the right side there were a few blocks, and one was Redfish. John Liang from Intel is working on supporting the hardware management profiles. And he's also a lead in the BMTF organization. So I think John Liang would be the person to get in touch with for all the telemetry related information that you guys need.
Yeah, beautiful. And just to, give you guys a little bit of heads up, Google's working very heavily with the Redfish committee right now. The biggest gap that we have in Redfish is it presents a really nice logical model of the machine, but in some ways we need a physical model of the machine now, and they're extending Redfish to include basically connection info so you can see how everything's wired together physically. And then I think once we have that, we'll basically be able to say, we're all singing, all dancing Redfish, and all the proprietary things are starting to disappear.
That's brilliant. Yeah,
We're definitely interested in that. Thank you. Tiny Bay is the name you were trying to come up with, but that's good.
Thank you,
Hey,
Carl.
Dan, a question regarding Redfish. Is there an outreach to hardware vendors? For Redfish to work for different devices, right, they need to, provide the interfaces, the lower level interface to communicate with the VNC, right? And that's something that HP has been working on, but it has taken, right, on every generation, significant effort. So are there other efforts along not only, defining the platform, but defining the interfaces for the options and getting the vendors to comply at least to a baseline?
There's sort of two stories going on there in parallel. I'm not the complete expert here, but I can share what I know. There's obviously the hardware aspect of getting the necessary buses and things in place, and that's being driven mainly through our hardware team through the Open BMC card project, which I'm blanking on the name, right? But they have a name for that. And then there's also another project within Google called OVSS. From that, we have an Open BMC project that we are kicking off to try to drive standardization of how do you plug those interfaces into the BMC, right? Via that be IPMI, SMI, USB, whatever the protocol happens to be, right? and then how do you go and then extend that information to the outside world in the Redfish protocol? Because there's still a few things missing there, right? But that group has been very open to adoption. Some of the technologies we proposed, they had some issues with, primarily because they had dependencies on C, and some of our tech requires C++. But let me get you a contact that can talk more deeply about that than myself if you're interested in that, because I think HPE here could play a huge role in helping move the industry along with this.
Yeah, it also when you mentioned the physical model, right? We want to know the actual physical topology of connections to drives, controllers, networks, all that stuff. It's sort of we do it through we used to do it through the driver. In order for the BMC to gather all that information, right? You just don't want the list of the devices without the relationship within the devices, because then you wouldn't be able to build up the tree to ascertain that those connections are correct. So that's the main point. You would have to talk to the controller manufacturers, people from that make GPUs, people that make microsemi and storage, controller manufacturers to actually comply to what the DMTF is defining.
Yep, nope, for sure. Let me get you in touch with the right folks there. And then the connector model I was alluding to in Redfish, they actually do have an RFC out for that right now. That's in the DMTF archive, but I'll find the exact document and get it over to you.
Awesome, thank you.
Sounds good. Yeah. We're out of time this week. But yeah, thank you everyone for the very fruitful conversation. I think that was very helpful, and we have next steps planned for this. Yeah, we'll catch you all next week. Thank you.
You guys
Yeah, bye.
take care.
Thanks. Thank you very much.
Bye.
Thank you. Bye.